Hello everyone. Once again welcome to our online physics classroom. Children, in the previous session we have gone through dipole and dipole moment. So what do you mean by electric dipole? Two equal and opposite charges separated by a fixed distance constitute an electric dipole. The strength of dipole is expressed in terms of dipole moment. We also got an expression to find out the dipole moment. Dipole moment is a vector quantity and its direction is from negative charge to positive charge. Today we will discuss what happens to this dipole when it is placed in a uniform electric field as well as in a non-uniform electric field. Children, let's get started. Children, on the slide you can see a uniform electric field. So this represents a uniform electric field. Okay. Then a dipole is placed in this uniform electric field. So this represents an electric dipole. See, this is minus q charge and this is plus q charge. And this dipole is placed in a uniform electric field. The total length of the dipole is 2d. O is the center of the dipole. This O is the center of the dipole. And this distance is d, this distance is d. So the total length of the dipole is 2d. And P represents dipole moment. This dipole moment points from negative charge to positive charge. That means this is the direction of that dipole moment. So this dipole moment is making an angle theta with the electric field, isn't it? So here you can see the angle theta. This is angle theta. So the direction of the dipole moment makes an angle theta with the electric field. Now here we have plus q charge. This plus q charge is placed in an electric field. So it will experience an electrostatic force. And what is that force? QE is the electrostatic force experienced by the plus q charge, this QE. And what will be the direction of that force? Yes, since it is a positive charge, the force is directed along that of the electric field. So this is the direction of that plus QE charge. Now here we have a minus q charge. This minus q charge is also placed in the same electric field. Okay, electric field is uniform everywhere. So this minus q charge also experiences the same electrostatic force QE, but since it is a negative charge, the direction of force will be opposite to that of plus q charge. So here the direction of the force experienced by this minus q charge will be towards this direction. Okay, so this is the force experienced by plus q charge and this is the force experienced by minus q charge. Both the forces have equal magnitude, that is QE and QE, but direction is different. So these two forces constitute a couple. Why? Because these two forces are equal at the same time opposite. So two equal and opposite forces constitute a couple, and due to this couple, the dipole starts to rotate in uniform electric field. So whenever an electric dipole is placed in a uniform electric field, it starts to rotate. Why? Because equal and opposite forces which constitute a couple acts on the dipole. As a result, torque comes into play. So as a result, so this couple, the moment of this couple constitute. So these two equal and opposite forces constitute a couple, and the moment of this couple forms torque. So whenever torque comes, yes, rotational motion starts. So the dipole starts to rotate when it is placed in a uniform electric field. And it will rotate till it is parallel to the electric field. So here in this figure you can see this dipole is not parallel to the electric field. This dipole is aligned at an angle of theta with that of electric field. So this dipole starts to rotate and It stops its rotation when it becomes parallel to the electric field like this. Okay. So let's find out an expression for torque acting on this electric dipole. So the force acting on the plus Q charge is QE. Force acting on the minus Q charge is minus QE. So these two forces constitute couple. So how will you find out force? In class 11, you had already studied the expression to find out force. Torque is equal to force into perpendicular distance. So what is force? Force is QE. So QE into perpendicular distance. Which is the perpendicular distance? See, I have marked the perpendicular distance here. So BC is the perpendicular distance between the two forces. And how will you find out this BC? From the trigonometric expression, and this constitute a right angle triangle. Triangle ABC is a right angle triangle, and from triangle ABC, what is sine theta? From triangle ABC, sine theta is opposite side by hypotenuse. What is opposite side? BC, and which is hypotenuse? Hypotenuse is this. And what is that? 2D. So what is BC? BC is equal to 2D sine theta. So we have found out an expression for BC. What is that? BC is equal to 2D sine theta. So substitute that expression here. So you will get torque tau equal to QE into 2D sine theta. Then just rearrange this expression, write Q and 2D together. So Q into 2D into E sine theta. And what is Q into 2D? Yes, remember the expression for dipole moment. This is the expression for dipole moment P. Q into 2D. So we will get PE sine theta. So this is the expression for torque. And how will you express this torque in the vector form? Because you know torque is a vector quantity. So how will you write it express it in a vector form? Torque is equal to P cross E. Because you know A cross B is AB sine theta. So similarly, or AB sine theta equal to A cross B. So similarly, PE sine theta will become P cross E. Okay, so this is the expression for torque in the vector form, and this is the expression for torque in the scalar form. Torque is equal to PE sine theta. Now, let's see when this torque will be maximum and minimum. As you know, what is the expression for torque? Torque is equal to PE sine theta. So here when theta equal to 90 degree, what will be torque? Torque will be PE sine 90, and sine 90 is equal to 1. So torque will be equal to PE. So this is the maximum possible value of torque, PE. Then when this torque will be minimum? When theta equal to 0 or when theta equal to 180 degree, torque will be PE sine 0. Similarly, PE when theta equal to 180 degree, what will be torque? PE sine 180. Sine 180 is also 0. So torque will be 0. So when torque is 0, this is the minimum value of torque. When torque is 0, what does it mean? No rotation. Because torque is responsible for that rotational motion. If torque itself is 0, then that means it stops its rotation. Dipole stops its rotation. That means dipole has reached its equilibrium position. So what is the condition for equilibrium position? Torque must be 0. So this is very important concept. Condition for equilibrium position for an electric dipole is torque acting on the electric dipole must be 0. In that situation, the dipole will be aligned parallel to the electric field and it will stop its rotation. We know the condition for equilibrium. So this equilibrium of electric dipole are of two types. One is stable equilibrium and another one is unstable equilibrium. So when do we say that this equilibrium is stable? When theta equal to 0 degree. When theta equal to 0 degree, torque is 0. And this is the condition, or this is the alignment when theta equal to 0 degree. See, dipole moment is acting along this direction. That means along this way. And electric field is also acting along this way. So what is the angle between dipole moment and the electric field? Yes, 0. So this is the equilibrium position. And again, it's a stable equilibrium position because the dipole won't tend to change from this position. It always likes to remain in this equilibrium position. Now consider the next case, that is unstable equilibrium. What is this unstable equilibrium? When theta equal to 180 degree. Theta equal to 180 degree means what? Dipole is arranged like this. Dipole moment will be like this and electric field will be like this. This is electric field, this is dipole moment. So this is the arrangement for unstable equilibrium. In such a situation, what happens is that the dipole tends to move from this alignment and it tends to be in parallel to the electric field. That means it always tries to make an angle of 0 degree with that of electric field. So now it is, for an unstable equilibrium position, it is anti-parallel to electric field, but it does not like that position. It always likes to change that position and it likes to align with the same direction of that electric field. Okay, so this is the condition for stable equilibrium and unstable equilibrium of an electric dipole. It's very important. So you can expect a question like this, give an expression for the torque acting on electric dipole and also give the condition for stable and unstable equilibrium. So children, what is the total charge and the force acting on a dipole? Yes, dipole consists of a minus q charge and plus q charge. So total charge will become 0. Similarly, total force plus q and minus q force together constitute 0. Okay. Children, with this I am concluding my session. Notes of the topic and a YouTube video have been uploaded. So please go through that. Attend the test seriously and post me the answers quickly before 3 p.m. We will meet in the next session. Till then, take care. Stay home, stay safe, keep learning. Thank you.